So now we are going to see our next test, that is the shear strength of the soil. So our main objective of this test is to find the cohesion of the soil, denoted as C, to find the internal friction angle, denoted as phi. Apparatus which we require are the direct shear test, non-porous plates, the sampler, loading arrangement, that is the shear test arrangements, loading cap and the clamping screws. Since the shear strength is the summation of cohesion and sigma tan phi, so knowing the value of cohesion, we can find the value of shear strength. Coming to the pictorial view of this test, here is the arrangement of the shear box, which contains a slit here, and the soil, where the soil is poured in this shear box, this arrangement is like this horizontal arm and a proving ring. When a force is applied horizontally on this soil sample, it will show some readings in the form of proving ring. This proving ring consists of a dial gauge which will give us a reading, and knowing the proving ring constant, we can find the value of shear force. Since this part will get deflected when the force in the horizontal direction is being applied. Coming to the observation part, normal stresses will be increased in consecutive ways, and the shear force at failure will be known to us this part when the dial gauge gets reversed from its original value. Sample area will be known to us, and denoting these values we can find the values of shear stress at the failure points. From these, the graph will be plotted in between the normal stresses and the shear stresses, and the value of C and phi will be found out. Now we are going to perform this test. So now we are going to see the shear box arrangement of the direct shear test apparatus. So here are the porous stones which are paired. Now these are the porous plates, and along with it we are having the non-porous plates. The use of the porous stone and the porous plates are made in case of the drainage conditions are allowed. So we are going to do our experiment for the undrained conditions. So first of all, we are going to place this plate with the marking in such a way that the marking makes an angle of 90 degree with the horizontal force applied. So we are going to place this marking like this, plate of marking like this. Further, we are having this sampler which contains the sample which has been extracted from a soil which is at optimum moisture content. So we are going to place this sampler on the shear box, and we are going to place the loading pad on it, and we are going to push it with a very slow force. The sample has been placed in the shear box. Now further we are going to place these plates with the same arrangement of marking making an angle of 90 degree with the horizontal forces. Since the force is to be applied from this side, so it has to be placed in this manner. So now we are going to place this ball on the top. The function of the ball is to distribute the vertical load equally on the sample surface. Loading arrangement direct shear test apparatus, which consists of a proving ring containing a dial gauge in between, which will give us the reading for the shear force applied on this sample. Along with it, we are having this vertical loading arms which will operate the loads, and the loads will be increased in each of the following steps. Here is the gearbox, here is the on-off button and a machine. Even the manual use can be made to rearrange these particulars. After making a dial gauge to a 0, we are going to place our shear box in this box. Even the use of the dial gauge for the vertical readings can be made. So now, before operating our machine, we are going to remove the clamps of this test. So as the needle had stopped and started moving in the reverse direction, which means the sample had failed. Now we are going to do the same test after increasing this vertical load in our further test. We are at the observation part. Sample number has been 1, 2, 3. Normal stress has been increased 0.5, 1 and 1.5. The values of shear force has been obtained by multiplying the deflection with the proving ring constant. Area of each sample remained the same, 25 cm square. From that we had obtained the values of shear stress. Now plotting the shear stress on the y-axis and the normal stress on the x-axis, we have drawn this graph. Further extending this graph to the y-axis, where this cuts the y-axis, that distance is representing the C, that is the cohesion of the soil. Further, using the tan phi formula, that is slope, we can find the value of phi, that is the friction, internal friction angle of the soil. Here are both the objectives has been done, that is to find the C and phi. Further, the values of the shear strength can be found out using S is equal to C plus sigma tan phi. Thank you.